Oh, this is a tricky problem. It looks like, so it has that kind of basic flavor of a standard ACT problem where they ask you for an expression and there's variables in it, right? And they give you an equation, and then what you do is you use the equation to solve for those variables, so solve for a and b, then you plug in for a and b, and then you can just evaluate the answer. And they're very simple problems. Usually they're very low difficulty. This problem, on the other hand, not that simple at all. We have an expression that has two variables, a and b, but we're not given any way to solve for a and b. We just get a over b equals 3. So that is very difficult to work with. So what you're hoping here is we really have no other choice than to do a basic substitution, and we're hoping that this will work out to something trivial, right? Because there's not going to be any way to do any solving. So I mean, actually, to be honest with you, right at this point, since we know we're not going to be able to solve for any numerical values for these, you know the answer is going to have to be 0. But let's go through the substitution anyway, and see what it comes out. And we have fingers crossed that it matches what our instinct says. So a over b equals 3 can be changed into a equals 3b, and we can use that to do a substitution. So for a, let's put in 3b. So we'll end up with 3b cubed minus 27b cubed, and it's starting to look pretty good, right? If I take that 3 and distribute that, we end up with 27b cubed minus 27b cubed, which is 0. And as we suspected, it did end up canceling out. And it's lucky that it did, because we would have had no other way of solving that. If we had just, if this equation had, or if this expression had ended up with a b in it, we never would have been able to solve it.